You have to measure and you have to be accurate. Now let me do it first, and then you'll know how I want you to draw it. So number one, draw. Dutch here, I think. Draw a horizontal line. 3 centimeters long. Now I want you to do it in the middle of your page. Okay? So just horizontal means flat, in case you didn't know. And we want to draw it 3 centimeters. Okay? You guys got that? Number 2, I want you to draw a vertical line 4 centimeters. So by vertical, it has to be straight up and down. So it has to go straight up 4 centimeters. That's kind of important. So it should be 90 degrees right there. Okay, that should be 90 degrees. Okay. Try and draw as accurately as you can. See, we're having fun. Sean's laughing about drawing lines. Oh, he's chortling. So what I want you to do then is I want you to draw your third line, just connecting these two at the ends. What shape is that?
Triangle.
Good, but not specific enough. That's grade 8. What shape is this? Nope. Isosceles mean that the two sides are equal, but one's 3, one's 4, so they're not. Oh, come on, folks. Have a look. Okay, you gotta pay attention to details. What am I circling here?
Right triangle.
Yeah, it's a right angle. It's 90 degrees, so it's a right triangle. Okay, there's no such thing as a wrong triangle. This one's right, and that's because of the 90-degree symbol. Okay? You guys okay with that? Okay, so some of you with the triangles are going to be a little better off here. What I want you to do, okay. Oh, I don't know if that's 5 centimeters. Whoops, that was kind of dumb. All right. Okay. Anyways, what I want you to do here is I want you to measure this. Okay, if you think it's 5 and you measured it, it's 5. We got that. Ha ha ha. Okay. So I want you to draw a square. So 3 centimeters by 3 centimeters. Okay, now if you have, try and make sure to keep these angles 90 degrees as best as possible. So how you do that, eyes up here. Stop doing this, you. What I want you to do is from here, I want you to measure 3 centimeters and put a dash. Okay. Here, measure 3 centimeters and put a dash. Okay, then you know how far away it should be on both sides. Okay, and then you can draw this line, trying to line it up as best you can. Then draw the sides. Okay, that'll probably be an easier way to draw 3 by 3. Yeah, if you're using graph paper, that's awesome.
Oh yeah.
Good. Here, I'll switch to graph paper. I wonder if it'll line up. No, I was saying, oh well. Don't we need big graph paper? Okay, so then I want you to do the same thing here. So measure out 4 centimeters. Measure out 4 centimeters. And then draw that line and connect it, okay? So we want a 4 centimeter by 4 centimeter square. Okay, so when we find the area, we talked about squaring and square rooting. A equals the base squared. So it's 3 squared. So the area of this one is 9. Okay. And this is essential, right? How we go from squares to square roots. Square roots the sides. So what's the area of the red square? 16. Right? Base squared, area equals 4 squared. Now this is basic formula substitution. You do a lot of this in physics, but crazy formulas. Okay, so just get in the habit of doing it now. I know it seems so simple, but it's such a good habit that you'll be successful as you get older. So I have a question for you. What is 16 plus 9? Yeah, that equals 25. Okay. So what's the square root, though, of 25? 5. What did I just do there? Well, 25 is 5. Here's 5 in green. So if I draw this green square, 5 by 5, what's the area of it? 25. This is Pythagoras. That's what I did. So you guys have seen Pythagoras before. Okay? We have the red square plus the blue square. Now, we're not just adding them, though. Well, yeah, it is. Sorry. Red square plus the blue square equals the green square. When you, okay. Which one's the biggest out of all three of those? Right, the green one. It always has to be the biggest. Always. It can never, ever be the smallest. Okay. So what we can also then do, how would we find the blue square? Say we wanted to know the blue one. What would we do? Yeah, we would take our green. That's the biggest, so we're not going to add something to make it bigger. We would subtract the red square. Okay. So we don't have to use an arrow, we can use the equal sign. The blue square equals the green minus the red. Well, let's try it out. The blue, let's see, the green is 25. We subtract the red, which is 16. What's 25 minus 16? 9. Okay. So all the square stuff works well, doesn't it? But what's 3 plus 4? What if we don't use the squares? What if we go 3 plus 4? What is that? Is it 5? 7. Right? So it doesn't work there with just the numbers. Or what about 5 minus 4? Does 5 minus 4 equal 3? No. What do we have to find first? The area of the squares. So really we have to find the squares. It's all about the squares. Which one's always the biggest? The green. Okay, now in relation to the triangle, how would you describe that? Look at your triangle for a second. Is there anything particular about the triangle that would help you identify the green square? Well, is the green square touching this corner? No. Which one's touching this corner? Yeah, red and blue. So the green is not touching the corner. Okay. In fact, how could you describe it in relation to the corner? Away, good. Any other words? Away's a good one. Any other ideas? I can think of an A word. Ends with cross. Across. Yeah, it's across from 90 degrees. I can think of an O word. Yeah, opposite. Okay. It's almost like it's allergic to 90 degrees. Okay. So this one here, the green square, is opposite, or you said across, or away from 90 degrees. Okay. What can we call that side? Right? Now, if we're not if we're talking about the square, this side, I can always draw an arrow to it. Right? This gray arrow, I can always draw to the green square. So I start with my pencil at 90 degrees and draw an arrow. What do we call that line on a right triangle? Starts with an H, ends with a noose. Hypotenuse. Okay. So it's really important to know which one is the hypotenuse. Okay. So it's really important. Hypotenuse is a key word there. Okay. Now this, in fact, is only one of Pythagoras' proofs. Right? Just one. You can do this idea and prove this relationship many different ways. I think there's like 11, something like that. Way harder than this. This is the easiest one. Okay, but there's more than just one way of doing that. Okay. So any questions? Okay. So this is great for your understanding, because so often I see people trying to find this square by adding these two together. But that means the blue square is bigger than the green, and that can't happen. Okay. Do you know what we call these two parts of the triangles? Yeah, they actually have specific names though. This is the hypotenuse. These two would be legs. Okay, call them legs. You guys have any questions? How many people have done this before? Hands up. Good. Okay. We use Pythagoras all the time. It's like the beginning thing we do. In grade 10, anytime they're finding surface area or volume, boom, Pythagoras first, always. Okay, or they work backwards and do Pythagoras last. All right. So let's go to our notes. Let's find our notes and just kind of put more of a math spin on this, on the Pythagorean theorem. So, looking at our squares, this would be a by a, so this would be a squared. This side would be, this square would be b, so it would be b squared. And the green one would be c, so it would be c squared. Okay. So a and b, we would say those are legs. So we would say leg squared plus leg squared equals the hypotenuse squared. Again, it's the squares that we have to add or subtract. Okay. Let's put in here the 90 degrees. I should have had that in there. And you can draw an arrow to C, which is your hypotenuse. Okay, so I'll spell it. Hypotenuse is spelled right here correctly. Okay, hypotenuse. So, the formula is good and useful. If you want to find the hypotenuse, you guys are more used to having things start, right? So c squared equals a squared plus b squared. You're just more used to them being in that order. So if you find the hypotenuse, that's what you have to do. You have to add to find the biggest square. Okay. Whereas if you're going to find a leg, and it doesn't matter which one, okay, so it doesn't matter which leg goes where, okay, those things you can switch around like they're socks. Right. So, get it? Leg, socks? Okay, anyways. A squared, if you want to start with that, or b squared, it doesn't matter. But it equals what? The largest side minus the largest square minus a square. Okay, and I should do c squared in green, I guess. Okay, so when you're finding a small square leg, don't add to make something bigger than the biggest hypotenuse. Okay, keep that in mind. So let's do some examples. What is the length of the diagonal of a soccer field, which is 100 by 50? So let's let Dad help us draw a diagram. This is 100. This is 50. And so what we have to do now is draw a diagonal, which means you go from one corner to the other. Okay, it's helpful to have your measurements on the triangle. Okay. So we want to find what side? Are we finding a leg or are we finding a hypotenuse? The distance in gray across. Well, draw an arrow. What do we call that? That's the hypotenuse. So we're going to go c squared equals a squared plus b squared. C squared equals 50 squared plus 100 squared. Okay. So then you can go to your calculator, 50 times 50. That goes 2,500. I'm not sure why I use my calculator for that. And then 100 plus times 100. 10,000. Okay. So what we do now then is add them up. Okay. So we add them up. 12,500. Okay. So we have c squared equals 12,500. Sorry, there's not more room. And now what do we want to do? Square root both sides. So we're left with c equals root 1250. Let's go to one decimal. 111.8 meters. Okay. Questions, comments? Hands up if you've done this before. All your hands should be up because all of you have in grade 8. Okay, next one. So a square quilt is an area of 441 meters squared. Find the perimeter of the quilt. So let's draw a diagram. So the area equals 4.41. What we have to do in order to find the perimeter, keeping in mind that perimeter is the distance all the way around, so we're going to have to square root. So area of a square equals b squared. Substitute in 4.41 equals b squared. How do we get rid of b squared? What's the opposite of squaring? Square root. So then we are left with b. Go to your calculators. 4.41 square root 2.1. But that's not the answer to the question. That's one side length, and we want 4 of them. So the perimeter equals 4 times the base. So perimeter would be 4 times 2.1, 8.4 meters. That's our answer. Okay, 8.4 meters. Any questions? Okay, let's read the next one. A rectangular room that measures 5 by 3 is covered by 375 square tiles. What is the area of the room? Okay, so for a rectangle, area equals length times width. Get that from your formula sheet. You guys should know that one. So area equals 5 times 3. Area equals 15 meters squared. So what we have on here, we have 375 square tiles covering 15 meters squared. we want to know how much to cover 1 meter squared. So looking at equivalent fractions, how do you go from 15 to 1? What would you do to the fraction? Divide by 15. So what are you going to have to do on the top? Divide by 15. Okay, so go to your calculator. 375 divided by 15. So that equals 25 tiles per meter squared. Okay, that's what that fraction is. 25 tiles per meter squared. Okay. Oh, that's what the question mark. Well, yeah, I see what you're saying. There you go. Better? Yeah, it looks better that way. Okay, so what is the edge length of each tile? So what we have to do is draw a square, draw 1 meter squared. Okay, and what does that mean for our measurements? Well, this is 1 meter and this is 1 meter. So in here we have 25 tiles. How would we arrange 25 tiles in a square? 5 by 5. Okay, so 25 tiles would be 5 by 5. Okay. So if I'm going to draw that, 1, 2, 3, 4, there we go, 5 by 5. That means we have 5 tiles in 1 meter. Okay. So that's 5 tiles. How many centimeters? 100. So, how many tiles? Sorry, for 1 tile, what would be the centimeters? How would we go from 5 to 1? Divide by 5. What do we have to do at the bottom? Divide by 5. So 1 tile equals 20 centimeters. Okay. Now as a fraction, that would be 1 tile. Whoops. 1 tile over 20 centimeters. Okay. So, how many are home renovation specialists? Because this isn't quite the reality, right? It gives us a good estimation, but what assumptions are we making about the tiles and the floor? Any ideas? All the same size. What does that mean? Because they're all square tiles, right? None that are larger. Well, how would you get some smaller? What would you do to a tile to make it smaller? Cut it, right? If you look on the edge of the floor, right, does it finish with a nice square tile? No, it doesn't. Anywhere you look, it's not a nice square tile. So, now you guys are flooring experts, right? Sometimes you usually have to cut tiles, but we're assuming that no tiles were cut, okay? Which isn't the case 90% of the time. Have a look when you go into different rooms, right? Like McDonald's, their tiles, how they put them down, you'll see them cut all over the place. Some are good at putting down tiles, some are not good at putting down tiles, right? And they're all squares. You're working with squares and rectangles in the area. Okay. Any questions? Okay, read this one, underline the important information, and put it on your diagram. Go. Okay, so underlining important information is good for word problems. Don't underline the textbook though. Okay, so that's important. 2 meters per second. So what we should do on the triangle is this is 375. A to C is 975. So we want to find length BC. Okay. We need to find out the total distance because she has to kayak back, okay, all the way around. So what are we going to do to find BC? Pythagoras. Okay. So we know we have to square 975. We know we have to square 375. But should we add to make something larger than the hypotenuse or make something smaller? Subtract. Right? This is the hypotenuse. It's across from 90 degrees. We should subtract. Okay. Go ahead. Show some work, please. Okay, so look at my work here. I've shown something slightly different. Okay, in this step here, I transfer the squared and get rid of it by square rooting the other side. That's okay to show for work as well. Okay, so it shows you getting rid of the square root just because it's gone, I'm square rooting the other side. So you don't always have to show what I did in the red. What I did in the blue is perfectly fine for work. I can see what you did with the BC squared because you square rooted the 81,000. 810,000, sorry. Now in grade 10, that's your answer. Right? In grade 9, we go to the approximation. But in grade 10, we give exact answers. 900. Good. Okay. So, how far did she kayak? Add them up. Okay, she kayaked all the way around. Okay, 2249 meters. Okay. So this is her distance. What we're going to do is divide it by her rate, her speed. Yep. Okay, so this is 2250. Thank you. And that's going to equal her time. Okay. We call these dirt questions, distance, rate, and time. So 2250 divided by 2 meters per second. Equals 11.25 seconds. Ooh, that's not a good unit. What should we do? Yeah, divide it by 60. Because then we can get into minutes. And that equals 18 minutes. And now we have 0.75 minutes. We'll go times that by 60 to go back to our decimal, our seconds. Okay. So we take our decimal, 0.75, and that's in minutes. Now we have to multiply by 60 to go back into seconds. So 45 seconds. Okay. That's challenging to do. Okay. So it's 18.75 minutes. So this is a whole number. And we take this, 0.75 minutes, times it by 60 to equal 45 seconds. You guys okay with that? Okay, we shouldn't put 8.75 minutes. All right.